Good afternoon, everyone, and thanks for joining us this lovely spring day. My name is Rowan Braybrook, and I'm the Director of Programs with Northwest Natural Resource Group. NNRG is an ecological forestry nonprofit based in Seattle, and for the purposes of this webinar, we are also privileged to be the coordinator of the Puget Sound Seed Partnership. We have a number of seed-related events happening this year, including field tours and workshops. Starting off with our next field tour is going to be on May 7th at looking at a meadowscape restoration in Seattle. So if you are interested in seeds or related workshops, seed sourcing webinars, anything like that, please keep an eye on our newsletter, or also you can check on our website, and I will drop those links in the chat for anyone who's interested. Today we are excited to introduce Jeff DeBell. Jeff is Washington DNR's forest geneticist, and he is going to be discussing seed zones of the Pacific Northwest, which I know was a topic of high interest for a lot of folks. So thank you so much, Jeff, for joining us today. Jeff is going to start us off with a presentation, and then we'll have time for some Q&A afterwards. Many of you who join us for our fireside chats know we like to keep things pretty informal and have discussions. So we look forward to your questions and the discussion after the presentation. And if you have questions during the presentation, please feel free to drop them in the chat. I'll be monitoring the chat on Jeff's behalf. And just a reminder to please keep yourself on mute unless you are actively asking a question. And other than that, Jeff, I can turn it over to you for your presentation. Thank you.
Well, great, thanks. I'll share the screen, make sure we're good on that count.
Looks good.
Okay, just a minute, let me move this over. Okay, well, today, as you heard, I'm talking about seed zones. But the main reason the topic is on people's minds is climate change and its effect on how we make seed source choices. So I'll start by going over a little bit of history. And the reason for talking about history is to show that the way we're thinking about seed source choices in the future isn't really much different than what we've done in the past. The goals really remain the same, even if our techniques will be different. For people who aren't familiar with past systems, changing from the current system might feel risky because it can feel like the current system is the best system or the correct system. But I'm going to suggest to you there is no single correct zone system, but rather some principles that we want to follow when choosing seed sources. And the various zone systems are just a way to make those principles easier to follow. I also want to point out that if you have detailed information about the genetic structure of a species, there may be reasons for making decisions that are different than the seed zone approach I'm talking about. But for most species that we plant, we don't have that resolution of knowledge, and the intent of the seed zones is to help make good decisions based on general principles in the absence of more detailed information. So this photo is just a nice visual way to show why we care about which seed sources we choose and why we pay attention to seed zones. These are one-year-old trees just before packing at a nursery. Both blocks were grown in the same way for the same amount of time in the same place. The only difference is seed source. Now the two blocks, you'll notice, look different visually, because the trees are genetically wired to grow differently, which is what we mean when we say that plants are adapted to their growing environment. These two sources have different growth strategies, which is important for balancing the different risks the plants must deal with. So it's obvious that the source on the right is larger, but if you look closely, you'll also notice a lighter green color near the top. This is due to second flushing late in the season, which means added growth, but also comes with a trade-off that the tops are not hardened off until later in the season. The trees on the left didn't grow as large, but they're more hardened off. So why might these differences be important? So I'm going to suggest to you that they help deal with different kinds of risks on different growing sites. For instance, if a tree is growing out toward the coast on a very productive site, getting overtopped by other plants and shaded out is a very real risk. And that risk is probably higher than getting frozen back by an early fall frost, which would be less likely along the coast. So the trees on the right are probably well suited for that kind of growing environment. On the other hand, if a tree is growing at higher elevation in the Cascades, the risk of being overtopped by aggressive growth of other plants is lower compared to the coast, but the odds of an early fall frost are much higher, so it's safer to shut down and harden off earlier the way these trees on the left are growing. And a lot of adaptation in woody plants is related to the timing of growth, just like in this example. So I'll briefly skim over the evolution of seed source management in Pacific Northwest forestry because I think it's useful background. In our region, foresters started paying attention to seed source almost from the beginning of planting programs. One influential study was started in 1912 and involved taking Douglas fir from a variety of sources all over western Washington and Oregon and planting them on sites ranging from coastal to high elevation. They wanted to know if it mattered where the seed came from. And this study helped foresters see very early on that there were actually obvious differences among seed sources, and it was, in fact, important to select the right seed source if you want to have a healthy and successful planting. So, as this information started to come out, some of the first efforts at seed zones were made by the U.S. Forest Service, which first published guidelines for seed movement in the late 1930s, and then this early map of seed zones in 1944. The goal was to delineate zones of similar environment so that trees could be kept in the environmental conditions that they're adapted to grow in. So notice that these early zones were fairly long in the north-south direction, but are more divided in the east-west direction in a way that's often related to elevation. And that's because there's not really a strong north-south environment or environmental gradient, but as you travel east or west, there are significant weather influences with distance from the ocean or as you move up in elevation. Now, with any of the systems I'll show you, it's not so much that elevation itself is important, but that elevation is highly correlated with both temperature and precipitation, which are both very important. And because of that correlation, elevation is one of the most important things to watch in seed source decisions. Other landowners were also concerned about this same issue, and they tried to characterize environments in a way to help them with reforestation success. This is a Weyerhaeuser map from the 1950s that used growing season precipitation and frost-free period to define zones. DNR had something similar, and Manning Seed Company, which you would now know as Silvaseed, had their own zones as well. Regardless of the system, they were all trying to maintain a match between seed source and growing environment. Now, an important step forward was made in 1966 when geneticists and seed suppliers from across the region worked together to agree upon some standardized seed zones. It's important to note that this system was not based on known genetic differences among populations, but rather just on limiting environmental differences between the collection site and planting site, just like the earlier zones. It's also important to recognize that this system was designed to provide a standard method for recording seed origin, where the seed came from, as well as a guideline for seed transfer, or where you can plant the seed. That's one reason that the 1966 zones tend to be smaller in size than other zone systems. And if you aren't familiar with this system, it just divided the state into polygons or zones, which were then further divided into elevation bands. And then the idea is that seed would be kept within zone and elevation band. This system gave everyone a common language for describing both the seed origin and the rules for where it could be planted. And having this common language made it easier for the seed and seedling markets to function within the guidelines. And this was a big improvement from the situation where different organizations, had different systems. Then, in the late 1990s and early 2000s, both Washington and Oregon updated the published zones to reflect more actual genetic information about trees from research that had been done since the first common zones in 1966. The result was that the zones differed by species to reflect the reality that some species are more broadly adapted than others. And the zones are in most cases larger in size than the 1966 versions, again reflecting genetic research in addition to environmental variation. They still have elevational bands within each zone, but the width of the elevational band differs with species. Um, and it's important to say that these zones were mostly designed to guide seed transfer, not necessarily as a system for recording seed origin. Some people may use them that way, but others continue to record seed origin using more precise locations, either 1966 zones with elevations or even GPS coordinates with elevation. If you're thinking of native plants more than trees, a lot of people in the native plant world use level 3 ecoregions as seed zones. And while these zones are shaped by other factors in addition to just climatic variables, they still tend to compartmentalize environmental variation kind of in similar ways as the other zones, especially if you pay attention to elevation. And also in the native plant world, the Forest Service has developed a set of provisional seed zones that are based on a combination of winter minimum temperature and aridity, which is a heat moisture index. So this photo is just of Douglas fir coneflowers while I cover some ideas about adapting our traditional practices for the future to deal with climate change. So first, you've noticed that all but one of the zone systems I've shown are based on compartmentalizing environmental variation rather than being based on genetic data for the species we plant. This technique assumes that kind of regardless of species, plants are adapted to match the average climatic conditions where they evolved, including some variability around that average. And despite various zone systems having been used over time, I don't think I've ever heard of any seed source related problems that happened when people followed the system that was in place at the time. So this system of matching seems to work fairly well. Now, up until now, we've used geographic distance as a surrogate for climatic or environmental distance. And geographic distance is easy to measure and understand, and as long as the climate's relatively stable, work just fine as a surrogate. But with climate change, this is the part of our system that will no longer work properly. If projections are accurate, sites will move a significant climatic distance or environmental distance while staying in the same place geographically. So our task will be to identify collection areas where the historic climate was similar to the expected future climate of the planting site, so we maintain that match. So notice that the goal hasn't changed, and that goal is to limit the environmental distance that we move seed. But our technique for achieving that will have to be something more complicated than our traditional practice of just keeping seed geographically close to where it was collected. And that process is what I'll cover next. So this first tool I'll mention isn't directly used for seed source decisions, but it is used as a foundation for the other tools that I'll discuss. It's also handy for understanding what climate change might mean for your location. It's called Climate NA, which is short for Climate North America. And there's a web-based version for casual use as well as a downloadable version for more serious users. The helpful thing that it does is allows you to choose a location either by clicking on the map or entering latitude, longitude, and elevation. You can then choose a climate scenario and time period, and it will give you the expected values for a pretty good list of climatic variables that can help you understand both the historic climate at your area and how much that might change by different times in the future. And I think that playing around a bit in this tool can help move us from the general understanding that things are expected to change to a more concrete sense of just what this change might actually be like. Because we can click around on different cities or towns to look for current analogs or things that have similar climatic variables to what our area might feel like in the future. I think that's one way of understanding it. Many of you have heard of, and maybe you've even worked with, the seed lot selection tool. This was originally developed as a collaboration between the Pacific Northwest Tree Improvement Research Cooperative and the Pacific Northwest Research Station of the U.S. Forest Service, and it's available online for anyone to use. This and similar tools are what we need to be able to match historic climates of collection sites where the trees are adapted with future climates of planting sites where the trees will grow. This tool links information available from Climate WNA with a GIS system to provide maps of matching areas at a fairly precise resolution. It uses an index of climate variables to judge the match and then color codes based on the similarity of the climate index between the locations. You can use the tool to show planting areas that will be similar in the future to the historic climate of your seed lot, or you can use it to show collection areas that were historically similar to the future climate of your planting site. It's basically the same process, just used from different perspectives, depending on whether you're looking for places to plant a seed lot or you're looking for seed lots to match a planting site. Notice that just like the seed zone systems that we've used in the past, this tool also limits environmental or climatic distance between the seed lot and the planting site. The big difference is that this technique is accounting for the fact that the seed lot is adapted to the conditions of the past, while the planting site will experience the conditions of the future. And like most of the previous systems, it's not based on genetic data, but on environmental factors. Now, there is a place where you can adjust for species differences, and you do that by adjusting how close of a match you need. And that's done in the transfer limit section where you can do conservative or moderate or liberal transfer limits, depending on how closely adapted, how specialized your species is. And it looks to me, having watched this tool for a while, looks to me like custom features are continuing to be added for people who want the flexibility to incorporate their own preferences or fine tuning. But you can still use it with default settings if you don't have a reason to tweak those things. This tool is a similar tool called Zone Matcher, which was also developed by the Pacific Northwest Tree Improvement Research Cooperative at Oregon State University. It's also available online for anyone to use. For the user, I think the most important difference between this and the seed lot selection tool is that Zone Matcher is based on comparing entire seed zones rather than individual points or pixels. So that makes it a little bit more practical to incorporate into existing systems for larger organizations who deal with a lot of seed lots and a lot of planting sites. It may also be a little bit more intuitive for some people who are accustomed to using the zone systems. So with Zone Matcher, you select the zone system you want to use, which could be the 1966 zones, the 2002 zones in Washington, whichever, there's a list of different zones you can choose from. Um, it will then map matching zones, give you a list, in fact, which include elevation band, just like the seed lot selection tool maps the matching areas. And then in addition, you can compare the underlying climatic variables like temperature, precipitation, things like that, two zones at a time, your zone and one of the comparison zones. So you can actually see how close they are in temperature, rainfall, and that sort of thing. So one way that I think about Zone Matcher in terms of how it is pretty similar to the way we've used seed zones in the past. You can think about our past seed zones as a set of polygons that would be paired to a list of what we would plant in each polygon. But in the past, actually in practice, we've never really made the list because the only answer for each polygon was going to be seed from the same polygon. So we didn't really need to make the list. With Zone Matcher, we're actually going to make the list. And for any given polygon, instead of a single option, there might be several different options of seed from different areas that could be a good match to plant in that area. And additionally, with Zone Matcher, we have the option to make different versions of the list that would represent different times in the future. So if you think of it this way, our seed zones don't really need to change. All that we need to change is the list of what we should plant in the zones. And that's how we're planning to implement the systems in the future within DNR to help us continue to make adjustments over time to keep our seed lots matched to the environmental conditions without disrupting our existing systems. So finally, just a few little suggestions if you are in the business of collecting seed and managing seed or making decisions about seed sources. The first I'd suggest is to try to record your seed origin as precisely as possible, ideally with GPS coordinates and elevation. Um, and the reason is that would allow you to categorize your seed lot in really any existing system or any new system that might be developed. And if you're a seed collector and you don't want to reveal your exact seed collection locations, I think it's fine to introduce some offset in your GPS coordinates. I would just suggest if you do that, use the offset, the slightly displaced GPS coordinates at a similar elevation, because in some of the systems you won't enter elevation, you'll just enter latitude and longitude, and the system will look up the elevation. So you just don't want to do any random latitude, longitude if you're in the mountains, because you could accidentally be misleading about elevation. Secondly, if seed lots come from seed orchards, we might want to record the orchard name and the year collected in case the orchard is thinned or otherwise changed over time, so you know which version of the orchard the seed lot comes from. And just as background, Zone Matcher is actually in the process of being adapted to be able to handle orchard seed lots as well. And what's different about orchard seed lots is you might have trees from a lot of different locations in the same orchard block. So you need to be able to account for that and kind of calculate sort of the average, location that you would use for the orchard. Now, obviously, we're trying to predict the future and we don't completely know how the climate is actually going to change. These are projections. And we also don't know exactly how our trees will respond to that change. So when you're dealing with uncertainty like that and you want to be more comfortable with your decisions, I think one strategy is to use more than one of the available tools and look at some of the numbers, like I showed you could do in Zone Matcher. Look at individual climate variables like temperature and rainfall, or the mean cold month temperature, things like that. Or look at the elevation, look at how far geographic distance you're moving them in the output from different tools. If multiple ways of asking a question lead to similar answers, then for me at least, it's easier to feel more comfortable with the decision. Whereas if I get very different answers from the different tools, despite the fact that they're really kind of based on the same underlying assumptions and processes, that's reason to slow down and ask a few more questions. Try to understand why it's showing you something different. Maybe talk with people who know more about how the software functions, and that's how I kind of gauge things about how comfortable I feel with decisions. So that's what I had planned. So we can happy to switch to answering any questions, any things that might have popped up in the chat.
Great. Thanks so much, Jeff. Succinct, and you still managed to cover a lot of ground, pun intended. I will remove the spotlight just to give us a little bit more of a sense of who's in the room. We had about 37 folks in the room. Um, we are happy to open the floor to questions if the presentation sparked any ideas or thoughts or questions for you. You're welcome to drop your questions in the chat. You can also raise your hand using the React button at the bottom of the screen, or you can also come onto video and physically raise your hand if that's easier. Um, just to get us started, though, I know one of the questions I hear most frequently from landowners, a lot of folks have heard of the seed lot selection tool and do use it when they're trying to figure out where to source seeds from, but it can be very complex, all of the different variables that you can input. What are some of the variables that you tend to use the most often when you're trying to kind of triangulate an answer about where to source from? Are you using heat moisture index? Are you using the mean cold temperature? Or are you just using default settings?
So if I was using, say, Zone Matcher, which is kind of the direction that we're headed, that's based on an index that incorporates a lot of different climate variables that were pretty carefully chosen by researchers. So we tend to look at that index, but then maybe if looking at there, you can, as I mentioned, you can compare the individual variables. There's this place I didn't get into how to use it, and I wouldn't have time or be able to do that. But you can look at those individual things. And so if I'm talking about woody plants and especially conifers, one of the really big factors that plants tend to be adapted to is winter cold temperatures. So and it doesn't, a lot of these things are kind of highly correlated. So whether you look at mean cold month temperature or winter minimum or even mean annual temperature, I think that's an important one. And then because we're worried about warmer, drier conditions, we often will look, there's some heat moisture index numbers in there. I might look at that as a sense of how things go in warm, dry summers because of our climate. That's one of the real challenges, especially in the seedling stage. So those would be two things I'd pay attention to: temperature and then that heat moisture index.
Great. And I did see in the chat that Kathleen asked about if it's possible to share the links to some of the different online tools that you highlighted, and we can definitely share some of those. And it looks like some of them are also being dropped in the chat as we speak. It looks like Jim has his hand raised. Jim, would you like to come off mute?
Yeah, yeah. Hi guys. Hi Jeff.
Yep.
So for like the zone matcher and the seed lot selection tools, I suspect they're probably looking at projected future summer temperatures and precipitation or lack of precipitation. Do they also look at how well some of these species or some of these seed lots go into dormancy in the fall and how prone they are to growing later into the season? A lot of what I hear about, climate change is warmer and drier in the summertime, but we still need to get things to go dormant. Otherwise, that's a moot point.
Yeah, no, Jim, I think that's a great point and one that a lot of growers will key right in on. And the answer is that those tools are matching climate variables. They're not using genetic data per se, so that wouldn't account for that. And I know our nursery sometimes grows seed lots, and you may do the same. I don't, well, actually, you might not be given the organization, but when we have seed lots from Southern Oregon that people are growing with us, our nursery growers definitely see a difference in the kind of that, what you're talking about, the bud break and shutdown and all that sort of thing. So my guess is that's something that we'll have to sort of learn as we go, but it's not built into the tools.
Okay. That was that was my main question.
Morris, looks like you might have a question. But you
You're
are still
muted, Mert.
muted. Yeah. So if you go to the bottom left, you'll be able to unmute yourself on the screen. There you go.
Can you hear me now? Jeff,
Sounds
thanks for
better.
hosting this. It's it's really an interesting research project, and I'm aware that you have these different test sites where you're planting multiple seed sources in the same place to see how they grow. Could you just talk a little bit, an update on how many different sites you have over what range and the different seed sources and what you're hoping to find and how long it's going to take, 5 years, 10 years, 20 years to get results that you have a degree of confidence in?
Sure. Yeah. So what Merck's talking about is a project that we have going in DNR that's related to, some of you may have heard of the Seed Source Movement Trial, which is a big, pretty sophisticated trial the Forest Service has with a lot of different, this is Douglas fir in this case, a lot of different seed sources from California all the way up to the Olympic Peninsula, and have them planted in 3 transects from the coast up to the Cascades at 3 different latitudes, one up in Washington, one, and then 2 at different latitudes in Oregon. But that's only 9 sites, and that's a great study. But we want to, because of the importance of this, we want to have more observations. But we don't have the money to do a really big, fancy trial like that. So what we've done in DNR is assembled a similar range of seed lots. So we have, and this is in Douglas fir, but we'll be extending this to other species. Next in line will be ponderosa because statewide, you think of like the east side, ponderosas are really important species in the drier forests, and then hopefully keep going after that. We've assembled this group of seed lots, and we have 18 that are woods run seed lots. So from where we know to a pretty precise location, and representing a wide range of climatic environments, 6 in each state. So if you were to graph, that, like I said, winter minimum temperature and heat moisture index, we try to get a broad range of those things in each state, with all 3 states involved. And then we're planting them in as many different environments as we can. So we have some higher elevation up in the Washington Cascades, and we actually have some as far south as California. Not as many. It's harder for us to find people who will plant because when we don't run into them as much, But the idea is our model is that we grow the seedlings every year, and we will provide those free of charge to someone who will be willing to commit to planting them, and then measuring them routinely. It's easy, quick and easy measurements. We already have all the layout figured out. We give you the kind of the map and all that sort of thing. And we usually talk to the landowner, make sure it's an appropriate site, because sometimes landowners might want to do this where it's an underplanting, which isn't going to be good for Douglas fir. So we said, okay, that's probably not a good place to put our seedlings. Or someone talked to us one time who was really in ponderosa pine ground on the east side. We would love to talk to them again when we have ponderosa, but that wouldn't be a good place for west side Douglas fir. So we do have some conversations to make sure that these are kind of appropriate places. But that's how it works. Like I said, there's 18 sources with 6 from each state. Plus, we have 5 more orchard seed lots from DNR's program as kind of our standard, what we would normally plant. And to answer your question, Merck, about how many, I would have to double check with Stu, but I think after this planting season, I think we're up in somewhere between 25 and 30 sites at this point, and we hope to have up to about 50. So some of you on the call may have already seen some of these. We have a number of them in Washington. But if you want to get in touch, just feel free to shoot me an email. Rowan can give you my contact information, and I'll connect you with Stu. Stu Olszewski is our coordinator for this project. And then to get to the part that you ask about, how soon will you know things? Well, this is intended to be something that we watch for a long time because the climate we think is going to keep shifting. But I think you can start getting information very soon because part of the question with climate change is the balance between changing sources enough so you're better adapted in the future, but not make that so big of a change that you have problems in the short term when the trees are little seedlings. And so we can kind of get an idea of that risk right up front within the first, say, 2 to 5 years, have a pretty good sense of how are these young trees doing, even if we brought them from somewhere else. So we could answer that question in the short term. In terms of the long term, that's, that we'll continue to learn for decades. Did I miss any other parts of your question, or was that?
You did a really good job considering it had multiple questions included in my question. So thank you.
Yeah,
Sure.
very thorough. And we had a couple of questions come in the chat, and it transitions very nicely to this next question from Andrew. Is DNR looking at assisted species migration at all? What goes into decisions to assist species migration or not to?
So our starting point is no. And the reason for that is that the forests that we manage are more than just the trees. There's a whole suite of organisms that go along with that. And so if we're in an area that's traditionally grown Douglas fir, there's probably all these other things that are interacting with Douglas fir. So we would prefer not to then go and say, let's plant sequoia here. Not that there's anything terrible about that, but if we're managing ecosystems, we would rather find a seed source for Douglas fir that continues to interact with the rest of the organisms. Now, so that'll be our starting point. But having said that, we may get to the point where our choices are pretty limited and we have to do that. But even then, if you think about ecological amplitude, we do have west side ponderosa pine sources. There's some on JBLM, there's some in the Willamette Valley, and that exists on the west side right now. And it's hard to come up with a species that can handle heat and drought better than ponderosa pine. Once you get to where ponderosa can't handle it, you're kind of into sagebrush, right? Maybe juniper. You might have juniper. So, so we're going to try to maintain the kinds of forest types that exist now while we can. And then obviously you always have to be open-minded for the future if you just run out of options.
Yeah. And that's also probably a good time to note that there are different types of assisted migration. I know it tends to sometimes get lumped all together, and people are often thinking like, "Ooh, palm trees in the forest." But of course, there are different types of assisted migration. You have the assisted population migration, where you're moving species within their current range, their range expansion, and then there's species migration, where you're moving outside of the traditional range. So depending on who you're talking to, I'm sure probably there are half a dozen different answers with different levels of kind of risk appetite with different organizations about whether or not they're doing assisted migration.
Exactly. And that's why I tend to use, like you noticed, I just referred to seed source. And the reason for that is most of the forestry discussions that I'm involved in with big landowners, they're really mostly talking about what we're talking about
Mhm.
is maintaining the same species that we've been growing. And if you use the very broad term of assisted migration, you do get exactly what you just mentioned. Some part of the audience will start worrying about palm trees or something, which is just sort of distracting to the conversation. So I try to focus on just talking about the terms that we're talking about at the time.
Yeah. And we don't have to worry about palm trees because they wouldn't survive the winter anyway. So that
Exactly.
they, as you were talking about short term versus long term, they wouldn't last long enough to be a long term problem probably. Alicia asked, "What's the minimum number of plants needed to install at a site?"
Assume that you're talking about these trials that we were just
I think
discussing,
so.
and those are set up. It's just a minute, and I'll tell you real quick because we actually have them all boxed up and ready to go during planting season. It's whatever is it's 460 trees and it takes up 1 acre, just about 1 acre. And it's these are planted in rows that are 20 feet apart, but the trees are pretty close within the rows, only 5 feet apart, and then they get thinned out to 10 feet apart over time. And there's a whole long reason for this experimental design. And if anybody's into it, just get in touch with me. I'd be happy to send you a little summary. But what we're trying to do is minimize inter-source competition because we don't want a fast-growing source to shade out a slower one that might actually be good in the long run. And we want to be able to absorb some mortality up front while still having a good enough sample size for later. And we don't want an overly dense stand that as the trees get bigger will be get high height to diameter ratios and be real vulnerable to snow and ice break or wind throw or things like that. So there's a bunch of reasons for that. But in terms of size, right about 1 acre, 460 trees that we provide. And then if somebody wants to add some extra rows of their own seed sources, that's no problem at all. We just want the base set to be sure to be in there.
Right. And Eric asked if you had any urban sites.
I don't believe that we do. I can't think of any. If Stu is here, I could double check with him. He's out in the out of the office today. We're primarily on forested sites.
Great. I did promise to put some more information about in the chat, so I just dropped in information on how to find out more about upcoming events, and it looks like Nick raised his hand. Nick, would you like to come off mute?
Yeah, thanks. And thanks again, Jeff. So one of the persistent concerns that I see with a lot of these trials, and I'm sure you've wrestled with it internally, is how are we going to capture, monitor these results? I hate to say it, but you're not going to be around forever. And um, I just tend to see these kind of get squirreled away, or the information get squirreled away, and it's not widely disseminated. How do you, what kind of tools or what kind of resources do you foresee? What kind of organizations do you see helping um, keep this alive, this monitoring and this basically large scale experiment?
Yeah, no, that's a great question, and that's something anybody should be concerned about with a long-term trial. Because one of the things that is difficult, it's real easy to generate enthusiasm in the short term, but maintaining the workload in the long term is the challenge. And so we're approaching that in two ways. One is we're keeping the size of the plots, the commitment, and the measurements very, very simple. So it's not very hard to do. And then right now, we're acting as the central repository of the data. So it's in one place. I'm actually kind of hoping to migrate to where it's either someone like the Forest Service Research Station or perhaps the Pacific Northwest Tree Improvement Research Cooperative or some other institutional group. So it's not just DNR. I mean, we would keep a copy, but have them be part of it too. And then have this, because what we want to do, you can think of this as sort of like a citizen science type model, right? I mean, it's designed carefully. It's not just, random demos and stuff, but in terms of who's planting them and doing the work, there's lots of different people involved, and we want to have a good feedback loop. And we're getting to the point where I think we've been doing this for 5 years now, certainly at least four and maybe five. We're getting, and if you just have 1 year of results, that's not that interesting, but we're getting to the point where the results should start to get more interesting. And so we need to build in the feedback loop so the people who've agreed to participate and plant these things can see the results of not only their site, but the averages from others as well. And so that's one of the things we need to work on. But that's a great question, Nick. That's absolutely one of the things we still have to develop.
Go for it.
So I'm going to add a little something to Jeff's, can you hear me?
Yep.
Response. Because I had a site that I offered for consideration. It didn't uh, meet the criteria, but it was really a beneficial visit by Stuart and Kevin. And the thing that really stood out and I was impressed and encouraged by is that they're both young people with a lot of enthusiasm at the beginning of their career. So there's a good chance, maybe hopefully they'll stay around longer than us old gray people and keep it going because from my experience, people that start things and they're invested in it personally, uh, as long as they're around, they're going to be advocates for the program that they were involved with at the beginning. So I think it was wise or lucky that you got young people out there on the ground visiting these sites and involved in getting these 1 acre plots going.
Yep. Totally agreed, Mert.
Great. Any final thoughts or questions before we start to wrap up? Alicia?
Hi, Jeff. Can you guys hear me? Okay. I was just curious, you were heavily involved with the last seed zone um uh issue, right, with DNR. And I was just curious, with all of the climate change, do you see there being a new evolution as things start to change? What would it take before? I imagine it takes a lot of resource and time to redo that. So I was just curious if that's on anyone's mind.
No, so what I didn't talk about today is we got some funding to work on long-term seed strategy. And so we actually have a planner who works with me on that kind of looking ahead, using some of these tools and coming up with a strategy for how we deal with these seed source things going forward, you know. And one of the things we've talked about is while some of that will be what we do internally with DNR, some of it could be um, an outward facing or publicly available tool because lots of you folks maybe buy from Webster or buy from the Plant Material Center or other places. And so if we had well, number one, anybody can use the tools that I mentioned, but maybe have something that's a little bit simpler and customized a little bit for what we're doing. And so I hope that we get there at some point. But there is, I think it is more complicated with climate change to put out seed zones because I can't remember, somebody earlier mentioned, people have different outlooks, different risk tolerances, and those sorts of things. And so much of that stuff kind of feeds into what is going to fit for your organization, and so as I mentioned in our system, I don't think that we will update seed zone boundaries. And in fact, we have some internal planning units that are sort of similar to scale of the 1966 seed zones. And I think what we will be doing internally is really working on the lists of what goes into each of those planning units. And then that can just be adjusted over time. And I think a similar concept could be used in the general public, and whether that's based on the 2002 zones or stepping back for the 66. Either way could work, and there's some kind of pros and cons of each choice. So uh, anyway, so nothing in the like right away, nothing's getting ready to be rolled out, but that isn't our thinking about how this work that we're doing can be, help all the landowners in Washington.
Great, thanks.
Great. Well, if there aren't any further questions, I think it just remains for me to thank you, Jeff, for taking the time to chat with us over lunch. Great to hear a little bit more about your projects and to dig in to some of the details around seed zones. I know it's a complex topic and one that frequently comes up in discussion. So I'm so glad that we were able to talk with you about that today. And I will be uploading this recording up online, and I will send out a email with more information to everyone who registered to the webinar, although I can't promise exactly when I'll get it online. It might be a week or two. So, but I will definitely follow up. But thanks so much, Jeff, for your time.
Thank you, and thanks to everybody who showed up.
Thanks. Have a good day.